Evening all. Am I audible?
Yeah, yes, sir. You are audible.
Yeah, good evening. So welcome back to today's FDP, and it's on building the next wave on Indian startup with advanced computing technologies. Today we are glad that we have with us Dr. Sanghamitra Dev, head of multimodal and generative AI, Chegg, USA. And today's topic is AI and machine learning for startup success in India. Welcome, Dr. Sanghamitra Dev. I hope you have joined.
Yes, I have.
Yes. Yeah, good evening, ma'am.
Good evening.
Yeah, so before we start this session, I would like to give a brief introduction of Dr. Sanghamitra Dev. Sanghamitra Dev is head of generative AI at Chegg. She leads teams working on conversational AI, multimodal models, and development of agentic systems. She works on improving student learning with Gen AI. Prior to begin in a leadership role, she was lead staff data scientist for several years. Our work involves building conversational interfaces with LLMs, recommendation systems, computer vision, graph modeling, NLP, architectural decision making, data pipelines, and machine learning. Previously, Sanghamitra was a data scientist at Accenture, where she worked on a wide variety of problems related to data modeling, architecture, and visual storytelling. She is an avid fan of Python and has been programming for more than a decade. Trained as an astrophysicist, she uses her analytical mind to not only work in a range of domains such as education, healthcare, and recruitment, but also in her leadership style. She mentors junior data scientists at her current organization and coaches students from various fields to transition into data science. Sanghamitra enjoys addressing technical and non-technical audiences at conferences and encourages women into joining tech careers. She is passionate about diversity and has organized women in data science meetups. We are really privileged to have you, madam, with us from Supreme Knowledge Foundation. And I would invite you to start this session.
Thank you. Let me see this.
Thank you, sir. Thank you, madam. Madam, from the organizers, Jay asks 1 minute from me for some technical verification. Just give me for 1 minute.
Sure.
Okay,
I am also trying to figure out how to share the screen.
Okay.
Okay, I have to get.
Any problem, Dr.
Can you see my screen?
Yes, ma'am. Yes, visible. Ma'am, you can start, please.
Can I go to slideshow? And it's still visible, right?
Yeah, it is visible. Fine.
Okay. Okay. Hi, everyone. I am Sangha. I work in the space of AI and machine learning. And today I'm going to talk about this whole space of AI and machine learning and how startups are doing in this space, and then how to do these applications, essentially. A little bit about myself. I know you did get a pretty big introduction. I did my PhD in astrophysics before moving into the industry, which was a while back. And then I won't go into the details of my jobs because we already heard that. But in general, I've worked quite a bit in the space of content understanding, language, and vision. And I really enjoy public speaking. And yeah, and I guess that's why I'm here. So going through today's agenda, initially I'm going to talk about AI and machine learning, what it means, and generally startups in India, like how different companies are doing. The next thing I'm going to talk about is building an AI-driven application, which is non-trivial, and I will talk about some of the challenges. Then I'm going to talk a little bit about agents and RAGs, since 2025 seems to be the year where agents and retrieval augmented generation is going to dominate a lot of the applications. And at the end, I'm going to talk about what keeps me up at night. What I mean by this is with Gen AI, you must have seen that there are a lot of prototypes that are out there. Like if you go and search, there'll be like prototypes on GitHub all the time. So what is like, even though there are so many prototypes, I wouldn't say there is like massive enterprise level adoption. And so why do we what are the challenges that keeps prototypes from going into production? And so that what keeps me up at night kind of addresses some of those. One thing I will say, I will show lists of different things, sometimes companies, just because we're talking about startups and we're talking about AI. These are lists that I have curated. They're not complete. There will be other companies that are different or better, and so they're not complete by any chance. So don't quote me on saying this is the best list. Moving on, the first thing I want to address is what is AI and machine learning? Now, this is like a very common diagram that you'll see if you search like AI, machine learning, and online. And this diagram is great. Like it kind of shows what each of these things kind of mean. Like deep learning, as you all were in the previous talk, like deep learning is working with neural networks, convolution networks, transformers, and other like neural architectures. Machine learning encompasses not just deep learning, but all other kinds of machine learning models like decision trees, random forests, support vector machines, logistic regressions. These are things that we have been working on for a very long time. And artificial intelligence is something that's supposed to encompass everything, and it is something that's supposed to be as good as a human in solving tasks. And when I say this, I will definitely say this with some grain of salt, because yes, artificial intelligence is definitely bigger than machine learning or deep learning, and it is able to solve a lot of complex tasks through reasoning, through not just machine learning, but combining machine learning and rules, combining machine learning and different kinds of APIs. But you still have to remember that at least the current systems are still built. Artificial intelligence is almost like a system that's built, that's like a multi-component machine learning engineering system. And the reason I say this with a grain of salt is because people assume that now that we have AI, now that we have these large language models, this vision language models, multimodal models, we probably don't need to do any of the work that we put in for machine learning, and we can just, take these things and ask these models to do anything, and it will solve it for your company. And I want to make sure that we don't think of it that way. We think of it, artificial intelligence, as this extra layer of things that we need to build to give us much better capability than just a single machine learning model. Any questions? Okay, moving on. I want to talk a little bit about AI ecosystem. And here again, this list is not definitely exhaustive. There are a lot of other models, other open source things out there. But the AI ecosystem has, I would say, mainly two kind of groups. One of the groups is externally hosted APIs, like OpenAI, Claude, Anthropic, Gemini, where basically you can call their API or have different kinds of call their API or have other forms of using models produced by these companies and solve problems that you're trying to solve. The other section of models are open source models, which you can either download and host it yourself and solve your problems, or you can download it and get companies like Amazon to host it for you. You can fine tune these models to solve your specific needs. Llama is a very typical example. There's Mistral in the space. And I've put the logo of Hugging Face here because Hugging Face is one of those mediums that basically give you the infrastructure to use these open source models. There's a large list, and you can use it in their framework. And I also wanted to put Saravam.ai here because it was very interesting. It's one of the Indian startups that's working on multilingual AI, and yeah, so that's another like interesting AI startup. Another very important thing I want to mention is that, like, why are we talking about AI now? Well, or by now, I mean maybe the last 2 years. Why weren't we talking about AI before? And like, what's significant now? So two things. Like, one of the things is um, we have huge amounts of data that have been procured and curated in a certain way that makes the large language models or the vision language models or the Gen AI models. Like, there's huge amount of data to actually give these models the capacity to behave in a way that it has like all-encompassing knowledge. That's one part. But the other part is compute. Like, we have there's like huge advancements in GPU compute that has led to the production of these models. And then semiconductor companies are doing really well right now. There's like NVIDIA has a market share, but there are like many other semiconductor companies that are researching this whole GPU space so that AI modeling can happen cheaper, faster, take less energy. And there's this huge group of Indian startups in this space as well. And it would be interesting to see what are the contributions of these startups in this space. Another important part of AI chips, and I bring this up because when we were doing pure machine learning, one model was being used for one purpose. And so inference was not, these were not big models first. They were typically small models. Any questions? Yeah, so when we were doing like small machine learning models, inference was not really such a big deal. Like, you could host those models in pretty like CPU-based machines, and a lot of the times they would work and they would be fine. Whereas now you have these models with 70 billion, 400 billion parameters. They're huge. Just inference itself is very expensive. And because these are all-purpose models, these models are being called for every possible, action, which also makes these models like very much high in demand. So another direction in which like AI chips are really working is how can we make these chips such that inferencing becomes faster and cheaper and also like takes less energy. So this is like another direction where like every company is putting in some effort. I was also looking into the Indian AI startup ecosystem, and
Hello. Hello. Yeah, I think we are unable to hear you. Hello. Hello.
somebody had muted me. Can you hear me now?
Yeah, fine now. Yeah. Please carry on.
So which side were you able to hear this?
Yes.
Okay. So somebody had muted when I was in the slide. Because I'm not in the window that has the Microsoft Office, so I can't see it if I get muted. So yeah, for this slide, the main thing I said was basically India is the third largest startup ecosystem, which is pretty impressive. And then there is like startups happening in fintech, edtech, electric vehicles, travel tech, like in all these different domains. It's a very active scene, and we expect a lot of really successful companies coming out here. So I was also researching like a list of startups, and here there's like this site I was looking at. It had a pretty large list, but things that struck out to me was Krutrim AI, which was also like multilingual, and basically it was like agentic, and it would help you in different tools. And then Kisan AI was also very interesting because it's in agriculture, and they're trying to make co-pilots that can solve your agricultural problems. So yeah, so that's the like startup scene. The other thing I wanted to talk about was, what are like the typical applications of AI? Like where can these startups go? And some typical applications are like the customer experience enhancements. So chatbots, personalized recommendations. This is very, very like common application of AI across different companies. There's operations optimization. There's like process automation, supply chain management. Can you still hear me?
Yeah, you are audible.
Okay. Okay. And then there is like product development. This is, I would say, a more newer application in some sense with the advent of large language models. So you can have AI-driven tools for faster iteration, testing of new product ideas. And you can also use AI to actually write the test of your engineering applications. So there can be here in particular, I'm talking about AI-driven quality checks in manufacturing and development, but there can also be AI-driven quality checks in your engineering pipeline. And then, of course, there's like fraud detection and other security areas in which AI can be applied. I'm going to take like a small break right now to encourage questions, because in the next section of my talk, I will break away from like this startup ecosystem and go into how do you build an AI system. I will not talk about modeling, but I will mostly talk about building. So are there any questions?
I have a question. Basically, we have shown mostly startups like in IT, edutech, and others. But there will be no startup for the construction companies, number one. And construction company is the backbone in the India right now, right? Where the investment is going around $1.5 trillion, especially in the infrastructure side. So why this is so? This is, yeah.
So why do you think, I don't have a very good answer, but why do you think there will not be startups in the construction zone? Just like Kisan AI, I could see a lot of AI investment in construction. So just to give you an example, in construction, like one of the aspects is architecture and design. And there are companies like Autodesk, which is, which is like part of AutoCAD in some sense, that it's not a startup, but they're heavily using three-dimensional large language models to solve like these three-dimensional architecture design problems.
But that is not but that is not end-to-end, madam. That is silos.
It will always be silos, right? Because construction itself is a very big problem, and AI cannot come in like, if you're thinking of like robots coming in and building the entire building the entire construction, that might happen in future, but we're not there yet.
No, it happens in India as well. The example is 3D printing, where you can build up and do.
There's some work happening in that space.
Yes,
and
yes.
But I'm pretty sure there is some human intervention there as well. Like it's always human in the loop, and having a startup solve a problem end to end. I would be worried about it as well, because construction projects are huge, and startups typically start small and become bigger and take on more and more. So solving parts of the construction problems from the startup point of view makes more sense, but a larger company could be doing the whole thing end to end. Any other questions? In that case, I will move on. And I'm mainly going to talk about, like in this section, about building an AI application. And this is something I have basically led teams who have worked on it. And the reason I brought this up is it's very easy to like have, go into ChatGPT and write some prompts and sort of solve the problem you're trying to solve. And of course, it won't solve problems related to like construction or related to agriculture, or maybe it can solve problems related to agriculture, I'm not sure. But it might solve like smaller problems. You can write prompts, give some information, and maybe solve some customer support problems. And that might lead you to believe that, okay, like, before I had to like have this team of customer support people or build this chatbot plus customer support people, and now all I need to do is call the ChatGPT API, and it will probably solve the problem that I'm looking for. So the whole purpose of like showing you this building an AI application is to make sure that you do not fall into that trap. And again, POCs are really easy to do because it's like the way large language models and Gen AI models work right now. They are very confident. They will give you very good answers. And unless you're a subject matter expert, detecting hallucinations might be pretty difficult, but hallucinations are like not the only issue when you're building an application for millions of users, for instance. And I have made things fairly simple and tried to keep it generalized. So like this is like a general pipeline that I imagine. So if you're trying to like build an AI application, you have to like go back to the drawing board and design your system. It's not just like connecting your customer to the chatbot API. It has like a lot of different parts to it, and I'll go through some of them in part. So the first step is collecting user information. Like you have to know your user's history, and correspondingly, you also have to know your product history, and you have to know about what is it that you're offering to the user. So that's one part. The next part is understanding why a user is here. Like why do they? Well, a lot of people don't want to chat. They probably want to go into a site and buy something, or they want to go and search for something. So it's important to understand what the user does and direct the user in the right direction. And the last step is, of course, serve the user, which I have made it pretty simple, which in the simplest case could be connecting to a large language model. But in most cases, it would be a complex system of connections. It would be connecting to some API. It could be the weather API. It could be the Google Maps. It could be something else. Or it could be, like take the user request, add some more prompts to it, and then send it to a large language model to give a user an answer to a question they're asking. And this is just like the flow of things. To make all of this work, you have to build a system that has high throughput, low latency, and like a scalable engineering infrastructure, so it cannot really fail. It needs to be up most of the time. You need a really good monitoring and evaluation framework. And I've put these as separate because the evaluation framework makes sure that it checks if your system is hallucinating, if your system is producing high quality content. And when I say monitoring, I mean not just monitoring the quality, but also monitoring the performance of the system. Is it going down at any time? Because typically these are complex systems with different components tied to each other. So you need to monitor each system such that if your system is down for some reason, you can go back and not just go back, you can immediately go and do like an incident management and figure out which part of your system is not working and solve for it. And before even you put something like this in production, you need to have a plan for something like this. And one more important point is making sure you're collecting the required data, logging whatever is required, and then having the right kind of storage for your system. So I'll go like a little bit deeper into each of these. So in terms of like collecting user information, these things are not necessarily new, but it's good to repeat. Like, what contents have your user generated in the past? What contents have they interacted with? Metadata, chat history, etc. With this, you also need to make sure that your product catalog or your content catalog or the APIs that you're connecting to, all of these are available, they are cataloged, and they are like well documented. So that's like the first step. The next step I would say is to understand the user intents. a lot of the times users do not want to chat. So before moving them to like the whole chat experience, you really need to understand what they want to do. And to understand this, you need like the correct, it's not just machine learning alone. You need a good front end and UI design. You need to do user research ahead of time to understand like, what are the different actions that your users taking. And then of course, analyze historical data to see like what are the different intents. Even when users want to chat, it might be that users need different chatbot personas. So that's where the historical data comes in. You can use the historical data to create personas for cohorts of users who can be answered or who want to chat in a certain way. So now I wanted to go like a little deeper into the architecture, and this architecture is motivated by some of the systems I have built. And as you can see, it's a very strong multi-component system. And the way it works is that your user comes in and interacts with the front end. And you need like moderation both with content going in and content going out, because you're in this world of large language models. And Gen AI, there are different kinds of hallucinations and different kinds of security issues as well. So you need to make sure there are filters to detect them. And then you can send the user request to the AI agent. The AI agent will use NLP model, machine learning models, or other kinds of models to figure out, what is the content that has been sent? Are there image components? What are the intents of the users? Once it figures that out, it'll go to this system called prompt store. I particularly put in prompt store here because when we talk about prompts and prompt engineering, we talk about it in a very offhandish way, like you write some prompts and you get what you need. But when you're building a system, your prompts need to be versioned, and they need to be versioned. They need to have IDs associated with it, so that when your system works, you know which prompt went with which information to produce some data. So when you're debugging, you know how to improve the prompts, you know how to go back to your system. So once the AI agent like basically detects what the user wants, maybe the user wants search, so then it just goes to search and retrieves things and shows it to the users. But maybe like search, go ahead. Was there a question? Okay, I guess not. But maybe like the user does not want to search, or maybe what the user is asking for search is not enough. In that case, you basically send it to the module that works. So in this particular example, I have said that the agent found that there is images in the data, so it needs to use multimodal models, which again combines large language models, multimodal models, and produces some content. And then that content goes to the moderation API and it's surfaced to the user. Now, while all this is happening, it's important to log everything. So what prompt ID was used, what model was used, what the user ID, etc. So all of that information goes to a data store, and you need to have a separate evaluation and online monitoring framework that basically constantly monitors the quality of these results. And I'll go deeper into evaluations in future slides. I wanted to go like a little bit deeper into prompt engineering, and it is a field in its own. And a very simple case of prompt engineering could be, take most of the information that I'm giving you and create a resume for me. You could do that with ChatGPT, and you'll get a pretty decent. Probably get a pretty decent results. You may or may not like everything there. But then there are like more complex prompts where you're trying to solve a mathematical problem, for instance. So you basically write a prompt to say, these are the typical steps in this mathematical problem. This is an example of a problem. So you give it examples, you give it the different steps required to solve the problem, and that can make, and that way you can create prompt templates. You could have prompt pipelines where you're combining different prompts. And then finally, like the agentic framework is a framework where it becomes like a multi-component framework where you have prompts, you call tools, and then you combine all of this to produce the perfect content that you're showing to your users. The other thing that I would like to say is that prompt engineering is used for like two different purposes. One of them is to like generate content. So the response that you give to your user. The other task that prompt engineering is also being used for is simple NLP tasks like classification, NER, summarization. Now, you might argue and that for these tasks, you don't really need large language models. Like small models will work much better, much faster. So why even use like prompt engineering here? And the reason to do it is because it still takes some time to build, like even distill a large language model and create a small model. Whereas let's say you're a product and you're trying to experiment with different ideas for which you need like classifications, NERs, and all of these things, you could just use prompts to get these results. Now, this is where I would say this is more at a POC level and not at a production level. When you can do these experiments at a POC level and when you're happy with it, at that point, it might be time to distill a large model and create like a smaller NLP model such that your simple tasks are not clogging your system with like a large model. This is the only slide where I'll talk a little bit about modeling. So this is a question that it really comes to like every time you're building a product. Should we use external APIs? Should we use fine-tuned open source models? And then even for external APIs, you have the option to fine-tune. This is just an example. You could fine-tune GPT 3.5, but what is the best option given where you are? So it really depends on your use case. Generalized use case, external APIs work pretty well. And it depends on the price of what you're the price of what you're trying to build. So for instance, if cheaper models are good enough for your use case, then external APIs make sense. And of course, if you're using an external API, you're kind of dependent on the external vendor, and that's not great, especially if you think that they might have downtimes. But even in those cases, you could use like a combination of OpenAI, Claude, Gemini, so that if you have a downtime of one of the external vendors, you could use the others, but it still can be expensive. Now, having said that, like when you fine-tune open source models, and the time when you do it is when you have very specific data for your use case. And also the other thing is maybe like you don't need like a very large model. You can do like a 1 billion parameter model, which is good enough to, you can fine tune it with like the very specific curated data that you have, and those results are good enough. In that case, fine tuning is something you should definitely do because you're using a much smaller model and you're using it to basically cater to specifically your use case. One of the big cons of fine-tuning is that you have to figure out hosting. Like Amazon Bedrock gives like a pretty good platform for hosting, but hosting can also be expensive if your models are not very small. Sometimes in the past, people have done full fine-tuning. These days, people don't do it. People usually do like parameter efficient fine-tuning, but sometimes the models might lose like generalized behavior. But that's also very use case specific. In your use case, you might not need the generalized behaviors. You might just need a specific behavior. And I would say like right now, smaller models that are distilled and fine-tuned are becoming more and more popular in very in adjacent domains. For instance, we spoke about construction. So in construction, in that area, like in architecture, for instance, people are very specifically building models and working on fine-tuning models that will give you, like 3D design capacity. And that would be a fine-tuned model. That would be a very specific model. It wouldn't be like a generalized large language model or a generalized vision language models. And the last thing I want to talk about is fine-tune with like an external vendor. The really pro here is that if you were already using that external vendor, you really don't have to do any engineering changes. So you can just plug into the fine-tuned model. It is typically you'll fine-tune a model that's like less expensive than like the latest model. So it should save you some money in that way. And then, like you can use your previous prompts, nothing really changes. So that's pretty good. But then you're again tied to like your external vendor, and the code is a black box, and there's always a risk that it might get more expensive in future. For instance, OpenAI made Sora available to the public, and now it's like $200 per month. Of course, like we were not really using Sora in any of our applications. It doesn't affect us, but it's something to keep in mind. Like it's tied to the vendor, and they could increase the price even if the price works for you now. The other thing I wanted to talk about was token optimization and latency. So you have these huge models which have billions to trillions of parameters. This slide is a little old. I think there are more models now with like the number of parameters have gone up. And one thing you have to keep in mind is that every word costs money and takes time. And before going into details here, I would like to say like the token is the smallest unit of text that is required by these models for processing. And it is not always, we can think of it as a word, but it's not always a word. It could be a subword. So like those are like the tokens. Now to produce these, it costs money because if you have a 1.76 trillion parameter model, then at inference time, you have to make 1.76 trillion computations to produce a single word. So you really strive to either make your model smaller or make sure you do not send in too many tokens when you're calling the model. And there are different ways to deal with this. And you will, whether you're hosting your own model or calling an external API, at some point, you will reach your token limits because of the compute limits. So it's important to remember that it's important to know what your token limits are and design your engineering system such that once you're in the place of reaching that token limits, you basically either throttle or you do something else to make sure that you're not, your system is not failing. Like you can throttle and give your user the message, please, we will get back in a few minutes, actually, in a lot of cases. So some obvious techniques are don't use large language models for everything. For things like classifications, NER, and other places where traditional machine learning was working, please keep them working. Do not throw them away and bring a large language model. Also see places where traditional machine learning can work in your workflow and bring in smaller models. These days, models can take in like really large contexts, but context summarization also helps with token optimization. And then, yeah, those I would say those are the main things. Fine tuning is like, again, you can use smaller models, and that will definitely lead to better token optimization. Another way to think about it is also to use multiple vendors if it's within your budget, because a lot of the times the vendors might be giving you shared instances, and the load on those shared instances might be really high. For some reason, like maybe OpenAI has a really high load, but Gemini does not. So you might have a toggle switch where you can just switch to Gemini for some period of time, even if it's not the most optimal solution, just because the load there is working better. So these are like things you have to really think of when you're building a system with AI. The next thing I want to talk about is evaluations. So it's really hard to monitor and produce the highest quality content using Gen AI. Now, in a lot of cases, like question answering, a lot of companies had humans answering questions of users or customer support answering questions. And now they want to remove that and put Gen AI to, basically produce the answers. And large language models hallucinate. So, and they don't tell you when they hallucinate. And the uncertainty in the answers is not determined. And when you ask the same question twice, you don't get the same answer. So there's quite a bit of uncertainty here. And the best way to deal with it is to have very good monitoring around the system that you're building. So basically, we have used this startup called Galileo, which provides the monitoring environment, but there are a bunch of startups in this space. You can also build your own. It's basically taking the content that's being produced and computing a range of different metrics on top of it. So blue, rouge, you can have like tone, toxicity, is there sexism in the language? You can have like different types of metrics defined, and there will be some metrics that are very defined for your company. For instance, in edtech, like some of the metrics that are very defined is accuracy of the answers of the questions that's given. And that can be measured using like other large language models. But it's very important to have these monitorings. Having said that, like automated evaluations are more like guardrails. If accuracy and all of these aspects are really important for your company, you need to have like a small amount of data that's also being sent to experts. And one of the things like I have done in the past is you first create your prompts, you create your agents, you produce the content, and you run it offline for a while with humans, and basically come up with a set of metrics that are required to measure whether this is of high quality or not. Once you've come up with them, then you send it out to your actual users. And at that point, you send like a very small percentage of your answers to the humans, because, everything evolves, data evolves, user behavior evolves. So it's important to like constantly monitor what's going on. And then the rest, all of the data should go through your automated metrics, which are mainly guardrails. And if something fails there, that needs investigation. The other thing I would like to point out is if you're building something new with AI in your product, A/B testing is a must. And these are like, some metrics that I picked up from one of the A/B tests. But basically, you have to figure out with your metrics, what is the ROI of your AI product? Is it benefiting your users? Is it, deterring them from doing the things they normally do? Is it confusing them? So you need to have those metrics, and unless your product is actually winning in those metrics, there is like no reason to actually do the AI product. And how to analyze, if the product has landed, do your users even like the product? And in order to do that, you should have like a slow and steady ramp. Like you shouldn't just decide that, okay, my product is built, I'm going to expose 50% of my users, if you're doing an A/B test, let's say 50, to this product. You should like first just introduce it to a small percentage of your users and see, learn what the user wants, understand the diversity of the user, and then change the product. And by change, I just don't mean change, how you do your prompt engineering or your agent development, but sometimes you have to change your UI, like how people want to work with this product. And you like slowly ramp it up, and at each ramp you learn different things, improve your product, and ramp it up. Another important thing is to make sure you have the right instrumentation and monitoring, because let's say you have the product out to a few percent of your users, and you see that somehow user engagement goes down. But if you don't have logging and instrumentation, you will not know how to actually analyze it to figure out why it's going down. Is it going down because somehow a performance of a system is going down, or somehow like search is not working as well, or is it going down because the content generated is not very good? And the worst case scenario should also be kept in mind, that maybe you build an AI product and your users actually don't want it. So you should have like a kill switch as well, because it's better to like, if you're sure that the users are being deterred by the product, they really don't want to use it, it's better to like kill it and start new. Questions? So I will switch topics again. So that's why I wanted to like give like.
Do we have, madam? Do we have any maturity assessment metrics? For instance, you have mentioned about throughput. You have not mentioned about the efficiency. Let me explain you when we are developing some systems, for example, let's say construction, for example, there are two components into it. One is the productivity, and other is the production systems. Production systems refers to the throughput, and the productivity refers to the time, right?
Yeah.
In that way, we are going to analyze the assessment matrix. So, do we have any assessment matrix into to calculate the ROI? Because ROI depends on cost and time. Refer to the quality and
ROI,
safety.
yeah,
To the,
and ROI
yeah,
also depends on your use case. So if you're thinking
yeah.
of the use case of construction, the construction company needs to actually define what the metrics are. For instance, whatever metrics I showed, they were partly from the edtech arena, but they were also general. But in edtech, we go in very deep and we have metrics that are very specific to education, that are actually very specific to science. So in terms of construction, that's a very specific use case. You have to define your metrics. So let's say you introduce AI and your productivity goes down. It takes, like, previously it took, I'm just making this up, but it took 1 month to build something. And now it takes 2 months because you've made the whole system more confusing, which is possible. So, but those are metrics like you have to define in every domain. So they're not, I would say they're not generalized. Like in healthcare, there'll be something completely different and they will be like very strongly based on accuracy. So even if it takes long, like in healthcare, productivity will not be important, like accuracy will be very important. So every domain will have like a different set of metrics that are important and they will be very customized.
No, I'm not agree with your point. There is a system level approach. The name of the system level approach is last learner systems, which will carry all the end-to-end cycle into the construction. Maybe you're not aware with that, but yes, last learner system with respect to the lean processes are there, because there are two components in any other system, whether it is software system or the construction systems. There are project management and the process management. So you're talking about the process management, not the project management. So if you combine these two, we'll develop a systems, and that is why we are asking the point, that is, do
You're
we
talking
have
about
assessment
general
metrics?
processes, and I'm not talking
Yeah,
about general processes. I'm talking
I'm
about
talking
very
about,
specific,
yes.
very specific metrics that are very specific to use cases. And I would still say general processes in AI are not totally developed. It's definitely evolving. And and that is also one of the reasons it is not widespread. The adoption is not widespread, right? Because a lot of the general processes that worked without AI will not work with AI. So you'll need to redefine them. I mean, I think at the beginning you said something like, why aren't there startups in the construction space? And probably this gives some of that idea as well, right? What you have right now in construction space will not work if you build an AI system for it.
It will work, madam, because people are working in that way. But there are, as you mentioned, AutoCAD with BIM. There is a concept of BIM, building information modeling, where the integration has happened end to end, whether it is the equipment cycle or the material cycle or the labor productivity. So there has to be use case with respect of integration of all.
Yeah, I'm pretty sure there are so the AutoCAD example, I'm pretty sure there are overall metrics that need to be like, you need to satisfy them to introduce a new element to that product. Similar to, the A/B testing slide that I showed. Like there are overall metrics that you need to for that specific company that needs to be satisfied. But that is different from saying that if you bring AI in, you need to bring your own metrics to the drawing board as well. Anyway, I think I will move on from construction because I work very, very far from construction, so probably not the best space for me to answer questions. Any other questions? Okay, so switching topics. Right now, I'm going to talk about RAGs, or Retrieval Augmented Generation, and agentic frameworks. These I will talk in a very high level, at a very high level, and I'm talking about these because it's fairly hot in the market right now. RAGs have become like part of search for every company almost, and then agents are also being used by most companies. There are like numerous startups that are coming up which are building agentic framework for something. And even like Kisan.ai, or I'm not sure exactly what they're doing, but in agriculture, in coding, like in customer support, like agents are really being built in these spaces. So I would start with traditional search before going into RAG. So traditionally, what happened was, somebody you go into Google or any other search machine, give your content and press search. In Elasticsearch was being used in the past, and basically there is some matching index, and based on the matching index, I mean there are more steps in between, like query understanding and other things, but based on the matching index, you're served a set of content, and you go in and you click on the one that makes sense. With large language models, one of the things we know is that large language models hallucinate. And so we want to reduce hallucinations. So one of the things that we can do is give a context that is relevant to the question or to the prompt given by the user. So you, in this case, I wouldn't say you totally move, but you combine your traditional search with vector search. And vector search, I didn't really talk much about it so far, but vector search is embedding based search. It is semantic search. So it means that content that is more connected or similar in meaning gets surfaced, and you combine these two and you send very relevant content to the large language model. So in this case, it actually gets the context, and then it can answer the question use this context and answer the question quite well. So that's the premise of like generalized RAG. And you can use any number of models that make sense to you, llamas, GPT-4os, and other things. Now, the next thing I want to talk about is agentic RAG. And the idea of agentic RAG is that, what could go wrong, for instance, in the previous slide. So a lot of the time you might actually retrieve content that might not be totally relevant to the user's query. In other times, like when you send like a very long context or a very large amount of information to the large language model, sometimes it does not concentrate on all of it. So it might somehow concentrate on a part that's less relevant. So these things could happen. And even after using RAG, the quality of the content that you generate might not be very good, and you might think the LLM is still hallucinating. So to deal with this, one of the things that have been put in like an agentic system is once you retrieve it, you basically use another large language model or like an agentic system to score the quality of the output. And if the score is not what you want it to be, you do some query rewrites, you do some other, you do some other actions and do the retrieval action again. And maybe query rewrites, maybe prompt rewrites or things like that. And you kind of go through this loop until you get the proper score. Now, this looks like an infinite loop, so that looks quite dangerous. So typically when people implement these, they keep, you can only go in like 5 times or something like that. They keep a limit to how many times this scoring can happen. But the scoring can also help in another way. So let's say you have a system that humans could also answer if the large language model answers are not good enough. So scoring could also help you in, just maybe for these kinds of content, send it to a human rather than use a large language model. The other thing to keep in mind is this makes the system quite slow because you're calling, like you're going on this loop, you're calling the large language models multiple times. So this is also something to keep in mind because if you're thinking of an online system with like low latency, this is not going to work. But it might work in some cases where, you had async humans answering the questions and it took 2 hours for a human to come in and answer a question, whereas here this might work in 10 minutes. So you have to figure out like in what situations agentic RAG is useful. The next thing I want to talk about is agents. And So what are agents? So agents are supposed to represent our brain. That is, it is able to understand the environment, perceive everything that's around you, and then it's able to process that information, have access to like long-term and short-term memory, then have some kind of decision-making, planning, action, and then decision-making and planning. And based on that decision-making and planning, it can take some actions, like call some tools, or call a large language model or something else. And the concept of agents is not new. It's been used in robotics for a very long time. As a matter of fact, self-driving cars have like each of these units are broken down into several other units and have like a lot of detailed agentic work going behind the scenes to make it work. But they become particularly interesting in this landscape where you have Gen AI models and large language models, because now you're actually able to solve for some very complex tasks by making this like multi-tool system that can do various different things. Like that can answer you like what is the weather. It can also maybe plan like a travel trip for you, or it can plan like a business trip for you. So it can do like a range of different things given these parameters. And there is typically like for a lot of use cases, I would say there is typically human in the loop. So let's say like the agent goes ahead and the agent has enough information to buy your plane tickets. You probably still want the human to go and approve it, because we're not that advanced yet that the agent can take all decisions by itself. I also wanted to put like a slide on the agent tech stack. There are various different like agentic APIs. One of the platforms that have become very popular is LangGraph. And I see like posts from LangGraph where they're making hedge fund agents, they're making like multimodal search agents, and like customer support agents, and there are like in each of these fields there are also a bunch of startups like basically creating these agents. So it's a good idea to like go in and look at what all of these companies are doing. And here observability means like these are the companies that are used for monitoring and tracking and making sure like your system works. So this is pretty much my second last slide. And I wanted to like put in all of this together and sort of talk about what keeps me up at night. There are like so many different things that you have to worry about when you're building a system. And if each of these fail, and I spoke about most of them, I think, where if each of these fail, your system will fail, your users will be unhappy with what's going on, and you're going to lose business. And I don't think this list is exhaustive. There are, I'm sure, other elements that I'm missing from here. But it's important to keep an eye on all of this, and it's important to have a strategy to actually improve and have a roadmap for how these things evolve. And that is what makes like going from POC to like a production level LLM so difficult. And I also think that's why like the adoption is slow, because a lot of the well-established companies have. Sorry, I didn't hear.
Are you presenting the slide, madam?
Yes.
It is not visible actually. Okay.
Okay. The share button is on. So, okay, so I think I cannot share. Only meeting organizers and presenters can share. So somehow my share privileges are gone. So someone else has to give me the share privilege. So from when were my slides not visible?
Just 1 minute back.
Okay, so somehow the share I cannot click on share, basically. It says only meeting organization and presenters can share.
Professor Dash, can you please resolve the issue?
I can also leave and join again, if that helps. Let me leave and join again. Okay, I still can't share.
Professor Shubrata Dash, you there? Can you hear me? Hello?
Were you able to see the slide on agent text map?
No, ma'am, slide is not yet visible.
Okay. I mean, I have two more slides, which are mainly text, so I could put it, well, that would be hard to put in the Q&A. I mean, I could read through my slide because it is text.
Yeah, you can do that. If the
Yeah, so let me
issue
read through my,
continues, you can do that.
yeah. So basically what I was talking about is what keeps me up at night. And then I've listed most of the things that I've, I think someone, yeah, so most of the things in the slide is things I've spoken about before. So like fine tuning versus external API, token optimization, making sure your evaluation framework is robust, prompt engineering and prompt versioning. This is something also where things go wrong very often because people don't always use the right version of the prompt, even if they have been developed. Should you build small large language models or should you use prompts for some ML tasks? This is also one that kind of there's a pull and push because if you use prompts for ML tasks, your work gets done much faster, whereas it takes time to build the small language models. So it's always like, where do you put your resources? When and where should you use RAGs? Do you have the right data store and instrumentation such that if something goes wrong, you can actually go in, do a data deep dive and find out what went wrong? There's moderation and safety guardrails, which is not always easy because models are evolving. So safety might be broken in ways that are not yet established. So again, there, like monitoring is very important. Then, A/B testing, like what should you A/B test? Because there are like so many different options. There's different prompt versions, different A/B agent versions, different types of LLM models. So in principle, you have to do a lot of offline experimentation to figure out what is the best thing to A/B test and show to your students or users. And then there are a lot of engineering challenges if you're trying to do like a streaming content for the users. And at this point, it's also important to think, do you actually need streaming content? And then in my last slide, it's basically, it's like the conclusion, and that when you're building something with Gen AI at scale, you're constantly like juggling between fine-tuning, machine learning models, quality, cost, latency, engineering infrastructure. Like where should you, like you need a strategy to be investing in all of this, but you might not always have the resources. So basically you're juggling among them to figure out the right resource for that makes your users, that gives a good experience for your users. Yeah, that's all I have.
Thank you, Dr. Sanghamitra Dev. Anybody having any questions on this particular session, feel free to ask.
Dr. Dev, thank you very much for the excellent session, number one. And I have a question here. So suppose like startups, whenever they're trying to take AI techniques and AI tools to the business, do not you think that somehow, as far as the return on investment is concerned, they cannot compete with the giant organization? If you're talking about LLM and other people, definitely giant organizations are having better strength compared to a startup. So suppose if I am with my students.
So I don't think that's totally true. So startups have the advantage of being nimble, and they have the advantage of not needing to worry about brand. So these are like some of the advantages of startups have. Like a startup might have 5 clients, right? And they might be able to work with like 5 clients and make progress really fast. Whereas like a giant company might have like a million users or, you know, several thousand clients. So making change there, the risk there is much higher. So I feel like startups will be able to take a lot more risks compared to giant companies. Now, should startups go into the business of creating newer large language models? Maybe not, because again, like OpenAI, Gemini, they have so newer general purpose large language models or Gen AI models. I would say maybe not, because the space is quite saturated. But the most of the innovation will happen in the application space. In the modeling space, there will be work done for specific use cases. For instance, the use case that I mentioned, like 3D models for design, that is actually not solved, and it's not. I wouldn't say like the bigger companies have solutions there. So it is very much R&D to come up with like good 3D models for design. And I could see a startup coming in there and working really fast and creating like a 3D model that works really well for some very niche design case.
One more question, as you are for a longer period of time in United States, and particularly in the domain, have you seen there that the giant companies are sharing their work with the startup to get it done?
Sorry, I didn't get the last word. Giant companies are doing what?
Okay, so suppose there are a few giant organizations, like did you see from your previous experience that they are getting a job, so suppose on like your domain on NLP, and then they are sharing it with the startup to get it done? Have you seen such cases in US?
I would say there are collaborations and there are like acquisitions, and then there is open source, right? So Meta makes all of their models open source. There's Mistral, which is open source. So there's open source, which anybody can use. And then there is, I would say there are collaborations, and there's definitely like acquisitions of smaller companies to kind of add that element to like the giant company's portfolio.
Okay, thank
but all the companies are for profit, so unless it's open source, I wouldn't say that things are openly shared.
Thank
you. Any other questions? Yeah. So any other questions from the participants end? If no questions are there, then I think we can move to close this session. So again, thank you, Dr. Dev, for joining us. It was such a wonderful session and very much engaging. Many questions you addressed, and you gave a very vivid idea and very in a lucid manner that how AI and machine learning are booming in the Indian scenario and also in the global aspect. And I would like to invite Dr. Subrata Das. Subrata Das, you there?
Yeah.
Yeah. So for the for the conclusive words, I would like to invite you, and then we can close this session.
I'd also like thank Professor Dhruvasis for inviting me to this session. Like, thank you. I really enjoyed it. Enjoyed the questions and everything.
Thank you, Dr. Sanghamitra Dev. Thank you, Professor Sivdas Bhattacharya. Thank you, Dr. Dhruvasis Sarkar. Now, to conclude the session, I'd like to invite Professor Dr. Amit Kumar Phasne to end the today's session.
Okay, so today we come to an end of the day one of the 6-day online ATAL FDP on building the next wave of Indian startups with advanced computing technologies. So it was a great day today. We started the day with an inaugural session where our coordinator, Professor Dr. Subroto Das sir, he welcomed all the participants and the speakers. Then followed by our principal sir, Professor Dr. Dhruvasis sir, and principal madam, Tripti Guin Vishas madam. They also welcomed all the participants and the speakers. Then it was followed by Professor Dr. P.N. Basu sir, our distinguished adjunct professor of Supreme Knowledge Foundation and ex-professor of IIT BHU. He also elaborated about this FDP. So after concluding the inaugural session, we began a very interesting first session by Professor Orijit Mukherjee from TCS. He spoke about introduction to advanced computing and its role in startup. It was a very interesting session, and this session was coordinated by Professor Dr. Subir Kumar Das sir from Supreme Knowledge Foundation. It was followed by another session, session 2 by Dr. Sanghamitra Dev from Chegg in USA, who spoke on AI and machine learning for startup success in India. It was again a very interesting session, and it was also very interesting, and it was very interacting also. I'm really thankful to both the speakers who have given their valuable time to share their expertise with all the participants. We are really grateful to both the speakers. Despite their busy schedule, they have spent their time to speak about these topics. Now, I'm really thankful to all the participants. We have got a huge response from the participants. Not only this, I saw that the participants were really very interactive. In both the sessions, they had very good questions to ask, and this made them both the sessions really very interesting. I'm really thankful to both the participants, to all the participants. Now, as we come to an end of the day, we have circulated a small feedback form in the WhatsApp group to get your valuable feedback so that we can improve upon if any. So we are really thankful to the participants. Now, as we come to an end of the day, let me just recollect. Tomorrow we have another. We are going to start tomorrow, the second day of the 6th-day ATAL FDP, where the sessions will be, the speakers for the sessions will be Professor Dr. Devashish Dev from Macau, who will speak about quantum computing, and the fourth session will be by Professor Samir Shinde from University of Oregon, USA, who will speak about supercomputing, accelerating research and development for startup. These are the two sessions which are lined up for tomorrow. I'm sure the enthusiasm which participants have shown today, it is expected the same enthusiasm the participants will also show for tomorrow, not only tomorrow, for all the 6 days. I'm really thankful to the participants. So with this note and with permission from our sir, Dhruvasis sir, we can end today's day. So sir, if you have permission, we can conclude this day with an expectation. Then tomorrow again we will meet with another two good speakers like today, with another two interesting sessions for tomorrow. So with this, we would like to end. today's day. So my best wishes to all the participants. Thank you. And I call it a day. Thanks to all participants. Thank you all of you. So we'll meet tomorrow again, once again, at 6 p.m. in the evening. 6 to 7:30 session 3 and 7:30 to 9 p.m. session 4. Okay, thank you all of you. Thanks to all.
Thank you, sir.
Good thing. Okay.
Thank
so,
you, sir. Thank you, sir.
Thanks all. So let us. Okay, so we can have now a photo shoot. I would request all of you, if you can switch on your video so that we can have a small photo shoot for today.
Okay, sir.
It's a request to all the participants. Tomorrow, try to join by 5:50. Thank you. So please hold a minute.
So if you are ready, shall we take a photo shoot?
Wait for another 1 or 2 minutes.
Okay, sir.
With this, we end today's session, and it's a request to join tomorrow by 5:50. Thank you all.
Thank you all. Good night, everybody.
Once again, thank you all. Hope see you again.
Sir,
Yes, please.
sir, attendance you will update, sir, daily, sir, or after all the 6 days, sir?
Sorry, sir. Can you please repeat?
Sir, in the ATAL portal, you will update daily, sir. Attendance, we should go and check and reply you back, sir, or after all the 6 days completed, you will update, sir?
We will provide the link in the WhatsApp group as well as your email.
Okay, sir.
And you will get all the update for the 6 days in your WhatsApp group as well as in the email. Am I clear,
Okay.
sir? So you will get touch with the WhatsApp group as well as your email.
Okay, sir. Okay, sir. Thank you, sir.
Okay, thank you.
Hello, sir.
Yes, sir. Yes, ma'am, please.
Sir, when we have to submit the online feedback forms?
At the end of each day, we will share a feedback form with you. Just it will take 1 minute from you to fill up that Google form, and at the end of day 6, you have to fill up a Google form in the ATAL portal.
On the ATAL portal. Okay, fine, sir.
Okay. Kindly note that the feedback form that we are circulating at the end of each day, that is only to get the feedback from you. That is not attendance actually, because attendance is automatically recorded by the Microsoft team. how not only attendance, the duration of time, the time duration during which you are logged in, it is all auto-generated by the Microsoft team. So that attendance we will get. Feedback is just for getting your valuable comments at the end of each day. Not only this, at the end of day 6, you will have to again fill a feedback in the ATAL portal. Okay, hope I am clear to you. Okay, thank you.
Thank you, sir. Thank you, sir.
Thank you. If you have any question, then you can ask. So we are going to end today's session. Thank you all. A very good night to all of you. Please join tomorrow by 5:50. Thank you all.
Thank you, sir. Both the sessions were highly useful and informative, sir. Thanks for arranging both the sessions, sir.
Okay, and kindly fill up the feedback form. It is not actually the feedback form. It is the valuable opinion we want to take from you so that we can improve our share.
Yes, sir.
Thank you
Yes,
all.
sir. Submitted, sir.
Okay, thank you. So thank you all and good night to all.